Lisa Kresge is the lead researcher in the Technology and Work program at the UC Berkeley Center for Labor Research and Education, better known as the Berkeley Labor Center, where she studies the intersection of technological change, precarious work, and social inequity. Her recent research focuses on data collection and data-driven technologies in the workplace, as well as union collective bargaining strategies in response to technological change. Prior to joining the UC Berkeley Labor Center, Lisa conducted research on farm worker health, housing, working conditions at the California Institute for Rural Studies. She has a multidisciplinary background in the social sciences, including anthropology, sociology, and community development. She will be talking about transforming data into digital technologies, how employers use worker data in the workplace. Lisa, the floor is yours.
Thank you so much, Christina. We're very excited that our sister organization, the California Labor Lab, is dedicating their annual conference to exploring these issues. As Christina mentioned today, I'm going to talk about data, transforming data into digital technologies. So it's building on Karen's excellent presentation, and I'm really just going to pull back a little bit to provide a framework for how we can think about these technologies. So before I start, I must disclose that I do not have any financial interests or relationships to disclose. So Karen touched on this a bit, but I thought I would start out to give you a bit of background about the Labor Center's Technology and Work program. We launched this program in 2018 in response to questions from our labor partners regarding the previous rounds of predictions of AI would lead to the end of work. So that paper that Karen showed from Frey and Osborne, looking at machine learning and the potential for replacing jobs, that prompted a lot of concern among our labor partners to find out really what does this look like on the ground. So we decided back then to commission some industry experts to take a deep dive into what's happening on the ground for frontline workers, in particular in a few low-wage industries that disproportionately employ workers of color, women, and immigrants. Those industries were the trucking industry, warehouse and logistics, food retail and e-commerce, brick and mortar retail, healthcare, and then most recently, the public sector. And as we suspected, although there will be some job loss, or there has been a little bit of job loss, it's only one piece of the puzzle of what we were thinking is that an equal, if not greater concern, were the effects of these technologies on job quality. So as a result of this research, we really decided that we needed to take a deeper dive into what these data-driven technologies are doing, as well as try to get our heads around the policy responses that are emerging to address these technologies. So what I'm presenting today are some findings from that field research. You know, we took a deep dive into technology conferences, vendors, vendor materials, demonstrations, patent applications, and we attended lots of events with our labor partners, labor advocates, civil rights, privacy advocates concerned with emerging technologies, and conducted numerous interviews. So a preview of what I'm going to speak about today, these are basically the main takeaways. So first, the trend. So the workplace is really becoming a major site for implementation of data-driven technologies. And the stakes are high across a wide range of industries. Employers are collecting worker data and using these algorithmic systems to make workplace decisions based on that data. And these technologies can have profound effect on wages, working conditions, equity, and worker power. The problem is that right now there's a virtual vacuum of regulation as it relates to workplace technologies. It's really the Wild West in terms of technology development and how employers are using these technologies. As a result, we're seeing a lot of response and concern from workers, worker advocates, as well as researchers. And we're increasingly seeing worker organizing, collective bargaining, and public policy aimed to really see that these technologies do no harm and in fact respond to workers' interests. So this slide is, I'm going to start with data collection as the first section. This slide is really, I'm not expecting you to read all of it. It's just really useful to start seeing what we're talking about in terms of worker data. You know, the point of the slide is to convey the sheer volume of and variety of worker data collected by employers. So the data collected includes data on personal characteristics, workplace behaviors, interactions, job activities, and performance. Some of these data employers have collected for a long time, you know, for example, credit reports or personality assessments. And some are, you know, not likely so prevalent for so far, like an ear print or walking gait analysis. However, as firms continue to digitalize their business operations and adapt new technologies that are based on data, we are seeing much more data collection and opportunities to collect data. So these are examples of several different data collection strategies. So employers collect data directly from workers, job candidates, as well as customers, you know, in the form of personality assessments or cognitive tests or customer surveys. Employers buy worker data from third parties, so background checks or social media profiles. They can extract digital traces from computers or network systems through the metadata or through software that's actually installed on the computer that can capture things like every keystroke. They can also detect and transmit workplace data using sensor technologies. So handheld devices, wearables, and equipment, such as RF scanners used in warehouses or GPS in vehicles. And finally, they can generate additional data through analysis of audio and visual speeds. So, for example, to identify emotional sentiment or worker activities. This slide shows a few examples of the first two strategies. So on the left is a screenshot of a personality survey question administered to job candidates as part of a job application for a major retail company. So it's basically a personality assessment. It's saying it's important to question authority. If my manager tells me to do something, I always do it. Is that most like me, somewhat like me, somewhat like me, or most like me? And so on the right is an example of a social media analysis dashboard that's provided by a background check company that analyzes workers or job candidates' social media. The company basically scrapes social media accounts and analyzes the data for keywords. The company markets themselves as a service to identify and flag bad content, which they specify as violence or alcohol and drug use, bigotry, sexism, criminal activity, foul language, or sexual content. But they also look for keywords of good content, such as donations, volunteering, or helping others. And importantly, the company enables employers to search for keywords that they want, such as work or the company's name, to look for brand reputation, a manager's name, politics, solidarity, to see if they show up in posts. So I'm going to turn to electronic monitoring. So the last three categories that I mentioned really fall within the electronic monitoring category. So for example, this is a screenshot of a vendor's dashboard for a computer monitoring system that's installed on workers' computers. The vendor basically captures continuous screenshots of an employee's computer. In this case, it's showing activity of an online video game. But you can see also on the menu on the left, on the side, it shows other options that employers can view, such as all of the different applications opened, the email, and the chat content. This is a screenshot from a promotional video for a system designed to monitor hotel housekeeping workers to ensure that they follow the exact protocols for cleaning hotel rooms during COVID. So the numbers indicate sensors that are embedded in the hotel room, and workers are also equipped with an NFC tag embedded in a wearable device, such as a wristband or a badge. And the system detects when a worker is essentially in proximity to each of these sensors. So that's the worker is supposed to follow the protocol from 1 to 11, and the sensor detects when they're in proximity to that, how long they were, and whether or not they actually followed the order. The system then pulls this data and analyzes it against workers' historical data. They can also compare it across different workers to gauge worker performance. These are some images of some of the more advanced computer vision electronic monitoring technologies. So these technologies essentially enable computers to analyze the data captured through video surveillance cameras and to classify the content to identify workers, workplace activities, and the work environment. So the image on the right is a screenshot of a system that's developed for the construction industry, and it's used to identify health and safety risks, such as whether a worker is wearing their protective equipment. These were also used during COVID to watch for social distancing protocols. The image on the top left is a system developed for the restaurant industry. And so this system basically classifies the different humans in the video and the activities, such as the restaurant guests, and the server, and looks at how long, for example, it took the server to greet the guests, or how often the server stopped at the table. On the lower left is a system that's in use that is developed to analyze the distribution of the ingredients on a pizza, to identify whether or not the pizza is in compliance with the company's specifications. So as is evident in these examples, emerging electronic monitoring technologies are incredibly invasive, can be at least, and enable data collection in unprecedented ways. So first, the electronic monitoring can be comprehensive. So as we've seen, sensors can be embedded in just about anything and collect a wide variety of data at a really granular level, even drilling down to the level of bodily functions of workers. Second, electronic monitoring can be continuous. So sensor technologies are always collecting data. They're passive in the background unless the sensors are disabled. These systems enable constant monitoring that can extend beyond the workplace, even spilling into workers' lives. So for example, GPS location tracking in vehicles and mobile phones can detect where workers spend their break time, or where they go when they leave work, and if they spend time in the same location, for example, as other workers, which has implications, as one can imagine, for organizing. Third, electronic monitoring can be instantaneous. So this really means that data collection analysis occurs in real time. The sensors are always collecting information and sending that information through the internet or other network systems to computer servers. So for example, these systems can produce reports that managers can view in real time on a computer dashboard or on apps on their own phones, wherever they are. Related to this, electronic monitoring can enable interactive technologies. So real-time data collection and analysis enables real-time communication and feedback. For example, with the pizza analysis system, it can send an alert to workers and or managers to indicate that the pizza is not in specification, and then the manager would require the worker to correct it. And finally, electronic monitoring is unavoidable. So many of the sensors are embedded in workplace technologies and systems that collect data for a variety of operational purposes, other than specific data collection of workers. This could be like inventory tracking systems or logistics systems, ergonomics, safety, and so on. So in many cases, the sensor system cannot be separated from the actual process itself. Of course, that doesn't imply that there are not choices around how that is accessed. So I'm going to pivot now to discuss the technologies that use all of this data. So data-driven technologies are basically digital technologies that transform data inputs into outputs. So they rely on algorithms, and I'm sure most people are familiar with algorithms, but just so that we're on the same page, I see those as a set of rules in computer programming code for solving a problem or performing a task based on input data. So the basic version of an algorithm resembles a recipe. So the algorithm is simply a set of instructions written by the programmer for how the computer should transform that data into an output. For example, in an automatic email vacation response, it will basically tell the computer to send an automated email to inform people who have just sent you an email that you are on vacation. But recent advancements in artificial intelligence research have resulted in much more complex algorithms that enable computers to learn, reason, and interact with humans in their environment. And these algorithms, often machine learning is the most common terminology, often become opaque to human programmers, let alone workers and policy makers. So as the algorithms adapt to new data, so that poses an interesting challenge to some extent. So a key takeaway, once again, is that algorithms transform data inputs into technology outputs given a specific objective. So this reliance on data is one of the reasons that we've seen just a huge surge in companies developing and deploying data collection and monitoring systems because they basically serve as the foundation for these technologies. So I think it's helpful to think about how this looks in the case of a system that is pretty well known, or at least well publicly presented in the media. So basically, in a system and warehouses that are designed to increase productivity through speed up and gamification. So essentially the input data comes from a variety of sources. The system draws from a database of product inventory and order data and location, warehouse location, product codes and quantities. It also draws from historical product scanning patterns. It uses the historical scanning patterns to generate productivity rate benchmarks, such as a unit per hour. And the system collects workers' current scanning data in real time as they scan each product code using a tablet, handheld device, or wearable. The system then analyzes all of the data in real time and produces a variety of outputs. For example, the system can produce a real-time display on the worker's handheld device that indicates their productivity rates or their scan error rates. The system can also send workers' productivity rates and rankings to a warehouse leaderboard display so that everyone can see it. The system can transform workers' scan data into a video game competition, and workers will be racing cars around a track with their scan rates as they're pitted against each other. Or the system can send time off task notifications for exceeding more than 5 minutes since the last scan. And finally, the system can send automated warnings, notifications to either the manager and or directly to workers. So I don't expect you to read this whole slide, but it does give you an overview of the different types of output that are generated by wide range of algorithmic systems. So for example, the algorithmic systems can output scores or rankings or classifications, such as a job candidate fit score, or systems can output notifications or nudges, such as productivity rate messages. Outputs can take the form of recommendations or directions, such as workforce schedules or driving route directions. They can include biometric authentication, such as thumbprint scans for time clocks. They can take the form of object identification, such as the construction site analysis for personal protective equipment for compliance. Other technological outputs can include allow the technology to understand human speech and text, such as chatbots or voice assistants. And algorithmic outputs can be embedded in hardware, such as robots or self-driving cars. So those were the different types of technologies. I'm going to pivot to the different technology applications, or basically how employers are using data-driven technologies in the workplace. So I think it's helpful to think of this in 4 different categories. One is electronic monitoring, which I already discussed in detail. The second group of technologies are used for HR management. So these technologies are often manager-facing. They're more, often more basic analytics, although they can extend beyond that. And they generally they generate information and analysis about workers to help managers make decisions about them. So they're basically decision support systems. So for example, systems for recruitment or hiring that make predictions about who should see job ads, or who might be productive employees, or who might be the best fit for the current workforce of that employer. Other types of HR analytics systems evaluate worker performance, or attempt to predict who might quit their jobs, or who might commit fraud, or who might be at risk of injury or of causing an accident in the workplace. A third set of algorithmic systems automate managerial tasks themselves. So rather than providing information to managers for them to make decisions, these algorithms manage workers directly by automating decisions. So some of the systems in that category are scheduling or coordinating decisions. Alternatively, some systems direct workers' decision-making regarding which job task to do next. And other systems are designed to motivate, basically, or influence worker behaviors with nudges, incentives, or games, which I already discussed in the warehouse case. And finally, the fourth set of algorithms, algorithmic systems, automate worker job tasks. So these task automating systems are, what most people, I think about what AI is. So that could be a virtual assistant like Siri, for example, so software embedded in a computer system or device, or they can provide the operating system essentially for robots or hardware, self-driving vehicles. As Karen mentioned, sometimes there's a continuum. Sometimes these are assisting workers to complete a task, and then at other times they are moving more towards a full automation. Of course, even in the cases where they are full automation, as Karen mentioned, it's often shifting work to other groups of workers, or the same workers have to support those systems. So some examples. This is a screenshot of an HR analytics system. So it's basically the dashboard a manager would see for workers that are completing video interviews. So the video interview plus a series of online questions and games to assess their personality and skills. So the system analyzes the assessment results and the videos and makes predictions essentially about which candidates are most likely to be successful employees. So in the center of the screen, you'll see an insight score, and that is a score from 0 to 100, based on how well their data matches the profile of employees that were evaluated as high performing by employers, which is very important. And managers basically receive a ranked list of candidates and their scores. And you'll see also that the hiring manager also has the opportunity to watch the videos and make their own rating, so to create the complete portfolio for that worker. So some images of algorithmic management systems. So the first image on the left is an in-store shopper app. essentially, it's a navigation system, and it has an aisle mapping database that delineates where each item is in the store. And then it provides workers with an ordered pick list to complete their shopping tasks. So the worker scans each item to verify the task and puts it in the cart. And then the system generates a wide range of metrics to evaluate worker performance as they shop through the store. The middle image is a similar system, but for hotel housekeepers. It is basically an application that directs housekeepers to each room as they are required to clean, and tells them the type of cleaning that they're going to be doing. And it can also send notifications to their mobile devices in real time regarding the changes in their tasks. So basically, if a guest is checking out or has requested towels, this system will change in real time and reorder their tasks if that is the setting that it's put on. And then the image on the right is a warehouse voice picking system. So essentially, that is a system that relies on natural language processing or speech recognition systems that provide workers with a verbal step-by-step instructions to navigate the warehouse and to pick items for orders. So basically, as they pick an item, the workers will verbally confirm the location of the product and the quantity to the warehouse management system. And then they're directed onto the next task. All of these systems, I should add, provide a means to electronically monitor worker activities and their location. And finally, in terms of the production task system, this is a floor cleaning robot that's used in grocery stores or hospitals or airports. And essentially, the robot uses cameras and sensors to perceive the store environment, including objects and humans. If it analyzes this information, decide it needs to stop or move ahead. If there's stop if there's an obstacle, or move ahead if there isn't. It basically relies on LiDAR signals for navigation and then scrubs the floor along the route. I should mention, you can see a steering wheel. The worker actually has to drive this through the store to map out the route so that the machine can learn. And then also workers have to support its functioning through maintenance and supplies. So I'm going to turn now to some of the potential effects. So I described the data inputs and the algorithmic processes and the outputs, and now we're moving to effects. So these are potential effects. Of course, I just covered a wide variety of data-driven systems, and they have very different functions and capabilities. So there's a wide range of effects that could arise. I'm not going to go through all of these, but I'll touch on a few. On the harm side, we have seen there's lots of evidence building on work speed up and injuries related to that, as we've seen with warehouse workers being nudged by algorithmic systems to meet quotas. We've also seen job de-skilling and lower wages as the jobs become more controlled and restricted. We've also seen a loss of autonomy and privacy, so with constant monitoring and algorithmic management. On the other hand, data-driven systems can be used in ways that are beneficial to workers. Often the same systems, it's just a choice on how they're deployed. So systems can decrease health and safety risks when used to identify worker exposure to hazards. Task monitoring systems can be used to upskill and empower workers by providing training or development insights rather than individual performance evaluation to managers for disciplinary purposes. So basically, a system can just show a worker the insights and not share it at the individual level to managers. Also, scheduling optimization systems that are often can create unpredictable schedules can also be used for the opposite, which is to facilitate predictable, flexible scheduling that workers can weigh in on which shifts they would like. So I want to take a moment to touch on the issue of equity. So equity is one of the biggest issues people are talking about in terms of the effects of data-driven algorithms. Often this has been much more in the civil rights community, looking at public sector use of algorithms for court systems, predicting risk for bail, etc. Or they're also used for in cases of predicting child abuse in some public sectors. So these systems have really received a bunch of scrutiny from particular computer scientists concerned with fairness and equity. And they've really highlighted the fact that, you know, bias in algorithms can really affect equity. For example, in algorithms that are used for hiring, scheduling, and monitoring or performance value, these systems can rely on data that is based on historical patterns of discrimination. And then these patterns essentially get baked into the system, which in turn reproduces those patterns in those technological outputs. Second, the industry is really at the forefront of adopting and experimenting with algorithms, often include many low-wage industries, which disproportionately employ women, Black and brown and immigrant workers. So it's exposing these workers to experimental, unvalidated, and often harmful digital systems. And finally, employment in customer-facing occupations, so restaurants or platforms, gig workers, where consumers electronically rate workers is another avenue. Consumers are biased, humans are biased, and so those biases are baked into those systems, which can really translate into problems when employers just directly move these ratings into performance evaluation scores and discipline. But the outcomes of technologies are not predetermined. I've hinted about this a bit, but it's not necessarily inherent to the technology itself. It really matters what context these systems are being developed in and deployed in. So these are really, they depend on the design decisions of developers and employers, and also in the context of the institutional context in which these are deployed. So the choices reflect that social context. And you know, we have a tendency to think of technology in a deterministic way. So like the robots were going to descend and take our jobs. But that hasn't happened yet, but there are numerous decisions that lead to their introduction into the workplace and displacement of workers. And it's important to keep in mind that this decision context really shapes what technologies look like. So one of a scholar, Yoshai Benkler, has really looked into thinking about technology and its embeddedness essentially in the social and institutional context. So technology reflects the cultural ideas and institutions, and they also shape technology. So funding priorities and decisions, tax policies, employer competitive strategies, relative worker power, existing laws, collective bargaining agreements, cultural ideas all contribute to which technologies get developed and how they're deployed. So knowing that, it's good to situate the workplace technologies into our current context. So as I mentioned at the outset, these technologies are really, they're exploding, and the venture capital firms have invested billions of dollars in startup companies. And this has really led to an environment where developers are creating systems and asking questions later, largely because this is happening in a regulatory vacuum. It's basically the Wild West to some extent in tech development and deployment in most aspects of workplace technology. Up until recently, we're seeing some movement, which I'll touch on next, but we're a long way from meaningful oversight of these systems. In terms of employment relations, Workplaces are shaped by employment and labor laws that tilt the balance of power towards employers. I mentioned the tax code preference. So we have a tax code preference for capital investment over labor, which incentivizes adoption of labor displacing technologies. Business models based on labor market flexibility and power. Business strategies that focus on customer personalization, which in turn empower customers over frontline workers, as I mentioned in the rating structures. These technologies are being developed and deployed in a culture of metrics and meritocracy, so placing math and technology at the center of decision-making. The tech industry is notoriously social homogeneous. There's a large level of social homogeneity, and which narrows the scope essentially of the experience of the developers and their insight into the limitations, as well as the adverse effects of these systems. And then finally, the historical inequalities and discrimination that shows up, that are baked into the data that are fed into these systems, are also part of the context of these data-driven technologies. This context can lead to a variety of issues. So what can actually go wrong? Well, with the regulatory vacuum that we exist in, there is basically a maxim of data maximalization. So collect all the data you can and then figure out what to do with it later. We're seeing some changes in terms of data privacy laws, which will be touched on later in this presentation and tomorrow. I've also mentioned the bias data problem. And then some of these systems are not grounded in validated science, or have faulty models, or lack full understanding of the human context and make inappropriate decisions. So for example, systems that purport to assess worker productivity through facial expression analysis, or scheduling optimization systems that schedule workers for back-to-back opening shifts, or hotel housekeeper optimization systems that send workers to clean a room on the 3rd floor, and then right after that they send the worker to the 30th floor and they have to push their cart to the elevator and move through that system. Or finally, bartending robots that overserve guests. These are all examples of systems that didn't work based on their limitations. Some of these systems are designed for one purpose, such as the inventory management systems, but then are applied for other purposes, such as evaluating individual worker performance. And finally, we've seen areas of misuse and abuse in technology adoption. So for example, time clock systems, when they first came out, they allowed for automated defaults for breaks, or they can round workers' hours, which enable wage theft, essentially, as these systems shave off hours. Or productivity systems that are designed to push workers to meet quotas at the expense of worker health and safety. And sometimes these systems can fail. As an example are the automated theft detection systems in grocery stores that falsely detect theft patterns among customers, leaving the workers to intervene and deal with that system error. Or there's a classic example in Japan of hotel room voice assistants that mistake guest snoring for voice commands and wake guests up in the middle of the night with responses, leaving the workers to have to fend for those systems. And so finally, I'm going to pivot just really briefly to some of the responses that we have seen to these technologies. There are several, a few different ones that I'll highlight. Are media coverage and organizing campaigns, collective bargaining, public policy, and data rights collectives responses. So In terms of media responses and organizing, there are several examples. Several years ago, Disneyland hotels introduced productivity leaderboards for their hotel laundry facilities. So they would be basically pitting workers against each other on their productivity rates. And the employees dubbed these systems the electronic whip. And the bad press essentially led to Disney eventually dropping that system. Another example is a startup called Predictum that offered a service that scanned potential babysitters for their social media accounts to score their risk level for the potential of drug use or bullying or harassment. Outcry over that system shut down their funding streams, and then they didn't move forward on that startup. As a final example, in West Virginia, the teachers' strike in 2018, to some extent, centered around the Public Employee Insurance Agency requiring workers to participate in a Go 365 wellness plan that required them to wear Fitbit trackers and hit a certain level of points to avoid paying penalties and additional premiums for their health insurance. We've also seen several examples of collective bargaining agreements. Some of these have been around for a while. So the Communication Workers of America, for example, have been negotiating a variety of provisions that place limits on the manner of electronic monitoring and limit the call monitoring really for training and development purposes rather than disciplinary purposes. Similarly, the Teamsters have negotiated the similar contracts over the telematics systems that are in their delivery vans, prohibiting the use of the monitoring data as the sole source for disciplinary purposes. And then several sports players' unions are really at the forefront at bargaining over biometric data collection. So many of them in their contracts have formed joint committees to review biometric sensor technologies, and some restrict the use of that data for determining pay for the players. And we've seen a lot of movement over the last few years in terms of the policy front at the local level, state level, and national levels. I'm not going to go into detail on this just because this is the topic of our colleagues tomorrow, but just to say that there are data privacy laws that are, California has the California Consumer Privacy Act and California Privacy Rights Act. And there are other states that have privacy laws, biometric privacy laws. We're seeing lots of proposals across the country as well. We've also seen some workplace technology policies, so specific policies looking at electronic monitoring, automated decision systems, and quotas. I think we'll hear about some of those tomorrow. Also, the White House has issued an AI Bill of Rights that really is looking at oversight over the design, use, and deployment of AI-based tools. And recently, the NLRB issued a memo directing vigorous enforcement of Section 7 rights in relation to electronic monitoring and algorithmic management of employees. And finally, what I'm referring to, Karl Buck's prefigurative politics, there are several examples where worker organizations are aiming to collectivize and leverage worker data to increase worker power and protections over the use of these technologies, and in some cases, empower workers to form worker cooperatives. So the Worker Info Exchange is in the UK, and they have developed a data trust to leverage gig worker data to increase bargaining power. They've been in several lawsuits against Uber, and Driver's Seat is a similar effort in the US. WeClock is an app that enables workers to collect their own data in the workplace to track their unpaid time, to track skipped breaks, to track how much time they are spending on their feet. And then finally, the Platform Cooperatism Consortium is a coalition of platform worker cooperatives. So rather than working for an external platform, this organization is supporting, and it's a coalition of groups that are developing their own platforms. All of these efforts indicate that workplace technologies have really become an important terrain for contestation, and the momentum is really building in the movement for fair and equitable technologies that serve the interests of both workers and employers. All right, thank you.